All right, everybody, a brand new chapter, a brand new start. Hopefully we'll do better. The tests are graded, and if I'm here tomorrow, I'll go over them with you. I'm not feeling very well. I'm hoping I'll feel better tomorrow. So let's start with some really easy things. So this whole next chapter is all about square roots, cube roots, etc., etc. Okay, so let's just write down some things on our notes that we should know. Okay, so first of all, let's look at what we call perfect squares. Please write this down. This is really going to help you a bunch, okay? So these are numbers we know. We know this, okay? We know that the square root of 0 is 0, isn't it? Now the square root of 1 is 1. Please write this down. The square root of 4, hopefully you know, is 2, because 2 times 2 makes 4. The square root of 9 is 3. Right? And I bet you could probably list the next ones. Square root of, what's the next one? Hopefully you've got the square root of 16 is 4. I'll let you catch up. So I'm just writing down all of what I consider the perfect square roots. Okay? We know the square root of 25 is 5. The square root of 36 is 6. What's next? Sure. Square root of 49 is 7. What's next? Square root of 64 is 8, right? Square root of 81 is 9. I'm going to write down some more. Square root of 100 is 10. 2 more. Square root of 121 is 11. That was in your warm-up. And finally, we know the square root of 144 is 12. And of course, they keep going, okay? Now, we can do the same thing then with exponents, okay? So, the square root of x to the second is x to the 1. Because what you're going to do is take half. We're going to take half our exponent, half. Ugh, can't spell. I'm not feeling well at all. Half the exponent, okay? So that means that the square root of x to the fourth is x to the second, because x to the second times x to the second is equal to x to the fourth, okay? Yeah, sure. What? Check it out. X to the second times x to the second is x to the fourth, because you add exponents, okay? X to the sixth, square root of x to the sixth is x to the third. Square root of x to the eighth has to be x to the fourth. X to the fourth times x to the fourth is not x to the 16th, but we add x. So x to the fourth times x to the fourth equals x to the eighth. Okay, so we take half the exponents. Now, if it's not an even number, all of these are even numbers, aren't they? Then we're going to make it even. So all of these are even numbers. Even exponents, right? Even exponents. So we're taking half the exponent, okay? So I'll let you write that down, okay? So here's what we need to do. We're going to take square roots. And when we do square roots, and you guys, I'm sure you did this in geometry, but you forgot it. That's all right, we'll go back through it. Square root of 27, so we'll get two things. So let's do example 1. What we're going to do is simplify, okay? Let's see if I can make sense of this. So if I look at the square root of 27, it's not a very nice number. 5.19615. That's called an irrational number, okay? It's called an irrational number. Because it goes on, it's like pi. It goes on forever, never ends, just gets ugly. It's an ugly number. Let's just call it an ugly number, irrational. So what we want to do is simplify it. So the way I do these, instead of writing the square root of 27, I'm going to write it as something times something with one of these numbers. Well, I know 27 is 9 times 3. So I'm looking for these numbers. I'm looking for these numbers. I'm looking for multiples of these numbers. Okay, so what times what makes 27? How about 9 times 3? So I'm going to rewrite this as the square root of 9 times the square root of 3. And now I've also have my x's. So I've got the square root of x to the 8th. Okay, so here's what we did. Square root of 27 is not a perfect square. I want to find a perfect square. And so I look at all these multiples and I find a perfect square. That's a perfect square. So now I'm going to reduce this square root. And I'm going to take the square root of 9, which I know is 3. Square root of 9 is 3. Just plain old 3. I'm going to take half of this exponent. We talked about taking half of this. So I'm going to take half of 8, which is going to be a 4x to the 4th times the square root of 3. So what we've done is we've reduced it. We've pulled out some numbers that will help us later, okay? All right, let's keep going. Hopefully you'll remember this. Example 2. When I look at example 2, this 3 is a regular whole number 3. I'm going to leave it on the outside. It's where I want it, okay? Leave the 3 there. Now 18 is not a good number. In fact, the square root of 18, I'll show you again, square root of 18 is an ugly number. Okay, so what times what makes 18? That's one of these numbers, okay? Don't use 6 and 3. Use 9 and 2. What times what makes 18? How about the square root of 9, the square root of 2? And now I want to take half of this exponent, so I'm going to take one away to make it even. So I'm going to write this down. Take 1 away. Like this. Square root of x to the 6th times the square root of x to the 1. Now I can't take the square root of everything, but I can take the square root of some things. So I look at it. Square root of 9 is 3. I know that. So I'm going to go, okay, this 3 times square root of 9 is also 3. So I'm timesing it. I'm going to take half my exponent. So half of x to the 6th is x to the 3rd. And then that's all I can do. Square root of 2, I cannot reduce that. Plain old square root of x, I can't reduce that. So the two of those, the square root of 2 and the x, can't be reduced, so they stay inside the square root. Okay, now I'm going to multiply. 3 times 3 is 9. X to the 3rd, the square root is 2x. Okay, there we go. All right, now I can also multiply. So I'm going to take a look at multiplying square roots. So I'm going to go ahead and multiply. Square root of 15 times square root of 5. Well, 15 times 5 I think is 75. So then I say, okay, what times what makes 75? What times what makes 75? Well, I think 25 and 3, because 25 is a perfect square root. Okay, I want to use 25 and 3, so I'm going to go, okay, the square root of 25 times the square root of 3, because 25 times 3 is 75. 25 is a perfect square root, so I can take the square root of 25 and I get 5 square roots of 3. Okay, we learned this last year. Hopefully it's going to come back to you. Example 2. 2 square roots of 3 times 4 square roots of 6. Whole number, square root number, square root number. So let's multiply. But multiply whole numbers to whole numbers, whole numbers to whole numbers, whole numbers to whole numbers. 2 times 4 is 8. Square root to square root, square root to square root. Square root of 3 times 6 is 18. Okay? Now we just did the square root of 18 earlier up here. So the 8 is a whole number. Leave the 8 on the outside. But 18 can be reduced. What times what makes 18? What times what makes 18 that has a perfect square? Well, obviously 9 and 2. Square root of 9, square root of 2, and then I can take the square root of 9. I know what that is. Square root of 9 is 3, so I've got this 8 times 3 times square root of 2. Now, 8 and 3 are whole numbers. 8 times 3 is a 24. So I'm going to have a 24 square root of 2. Square root of 2 is just another ugly number. You've got to leave square root of 2 as the square root of 2 because the square root of 2 is just this ugly number. 1.41 blah, 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 blah. Okay? All right. If this gets going too fast, you can always ask the substitute to pause the lesson. Okay? All right. Example 5. You cannot add them unless they're the same. Okay? Cannot add. Don't add unless the same root. Okay, don't add That's the same root, okay? So I can't add these two. Don't add them unless they're the same root, okay? But I can change them. So I can't add square root of 8 to square root of 18, but maybe I can reduce them, okay? So I'm going to try and reduce them. All right, so the 3 is a whole number, leave it alone. Square root of 8, well, that's just going to be the square root of 4 times the square root of 2, because what times what makes 8? I like that. What times what makes 8? Square root of 4 times square root of 2. Plus 5, 5 is a whole number. Square root of 18, let's see, we've done this one before. How about square root of 9 times square root of 2, because square root of 9 is a perfect square. All right, now, let's see. I'm going to try and simplify what I have. Square root of 4 is 2, so I'll have a 3 times a 2, square root of 2. That's just 6 square root of 2, right? Plus, on the other side, 5, because that's a whole number, leave it be. Square root of 9, I know what the square root of 9 is. It's 3 times the square root of 2. Well, all right, that's just 5 times 3 is just 15. 6 plus 15 is a 21 square root of 2. You can add them now. If you have 6 square root of 2 plus 15 square root of 2, how many square root of 2 do you have? You're going to have 21 square root of 2. Okay? Hopefully this is coming back to you. We learned this last year. Now, I'm going to distribute. So I'm going to go 3 square root of 3 times 2 square root of 6. 3 square root of 3 times 5 square root of 3. So I'm going to distribute. I'll do the same thing. Whole numbers with whole numbers, square roots with square roots, whole numbers with whole numbers, square roots with square roots. Okay, so let's go ahead and multiply this. So I get 6 square roots of 18. 3 times 2 and 3 times 6. Plus whole numbers to whole numbers. I get a 15. Square root of 3 times 3 is 9. Okay, now what can I do? Well, actually, I can do quite a bit. This is easy. Square root of 9 is 3. I know that. All right, so I get this. Let's just do the easy stuff. Plus 15 times 3. I know the square root of 9 is 3. Now the square root of 18, we've done that several times. We should be okay at simplifying the square root of 18. 6, and we'll simplify or reduce the square root of 18 as the square root of 9 times the square root of 2. And we like that because 9 is a perfect square. I wouldn't use 6 and 3. Square root of 9 is 3, so I'm reducing it. So I take the square root of 9. I get an answer of 3, so this square root of 9 becomes a 3. And 15 times 3, that's easy. That's just 45, whole number to whole number. And then 6 times 3 is 18, square root of 2, plus 45. Now, that's it. Don't add these because these are different. You can only add them if they're the same, and they're not. Okay, example 7. We're getting there. This is a FOIL problem. We're going to multiply this times this, this times this, this times this, this times this. Right? We're going to go this times this, this times this, this times this, this times this. Or more specifically, 2 square roots of 3 times 5 square roots of 3. Whole number to whole number is a 10 square roots of 9 minus whole number to whole number is 5, but we got to bring, 10, my bad. But you got to bring the square root of 3 with it because it's 2 square roots of 3 times 5, which makes it a 10 square roots of 3. Okay, inside, 1 times 5 is 5, but you've got 5 square roots of 3, so we bring the square roots of 3 with it. And then finally, 1 times negative 5 is negative 5. Now, one of the things I recognize is that you can add these two. They're the same. Those are the same. Remember, don't add less than the same, but these are the same. I can do that. I know what the square root of 9 is. I'm going to do that also. So I'm going to go 10. Square root of 9 is 3. Negative 10 square root of 3 plus 5 square root of 3 is a negative 5 square root of 3. When you combine those two, that I get a negative 5 square root of 3. Then minus 5. Okay, well, wait a minute. I still have some whole numbers. I'm not done yet because I've got some whole numbers I can do. Okay, 10 times 3 is 30. Right? Minus 5 square root of 3 minus 5. Okay, whole numbers of whole numbers. Whole numbers of whole numbers. I'm going to make that 25 minus 5 square roots of 3. Okay, that's what I got. All right, I'm going to turn the page. All right, now, here's a rule. If you have a number, any number, to an exponent, say P over Q, all right? If you have any number to an exponent, please write this down. Then you can rewrite this as a square root or as a root. We're going to rewrite this as a root. I'm going to write this as the Q root of n to the p. So let's write down what we have. The top number is the power. The top number is the power, like the, to the second power. And the bottom number is the root. So if I take a look then at example 8, and I want to just rewrite it. Okay, so we're going to rewrite this. The 5 is my root, and my 2 is my power. So I'm going to rewrite this as the fifth root. The 5 goes in. That's my root of 32 to the 2 power. Okay, I can do that. I do know this because I know that 2 times 2 times 2 times 2 times 2 is 32. So I know the fifth root of 32 is 2. Okay? So I'm going to have 2 to the second power. Oh, get a pen that works. 2 to the second power, because that's 2 times 2 times 2 times 2 times 2. So 32 to the fifth power is 2, and 2 squared, don't get that squared, is 4. All right, let's look at example 9. Can we rewrite it from root form to exponential form? Sure, it is going to be, so let's go the other way, from root to exponential. We're going to go this form to this form. So we know that that's my power, and that, so as a fraction, it'd be a 2/3. So we're going to have a 27 to the 2/3. I also know, if I need to solve this, that 27, let's see, 3 times 3 times 3. 3 times 3 times 3. 27 is 3 cubed, so I'm going to rewrite that as 3. And then 3 squared is 9. Okay, we're getting there. Example 10, let's solve. Okay, that should be easy. We can solve this. I'm going to just first divide by 2, divide by 2. Got x cubed equals, let's see, that goes in there, 30. So like any solving equations, how do we undo it? What's the opposite of a cube? It would be a cube root. So take the cube root of both sides, and I've got, and I don't know if your calculators will do this, but or your phones, but my calculator will. What is the cube root of 30? I'll show you where mine will do it. If I go into here, I'll show you how I do it on my calculator. I go to math. My math button, it's got a cube root. There it is. So if I want the cube root of 30, I get an answer of about 3.107, or approximately equal to 3.107. Okay, cool. All right, example 11. Almost done. Got to solve for x. There will be 2 answers. I know that because of what we learned last chapter. So first, let's get rid of the square, which is just square root. All right, that makes sense to me. Square root. Opposite of square root, so I get an x minus 5 equals 2 answers. It's going to be a plus or minus the square root of 50. All right, what's the square root of 50? I don't know. On square root of 50 is about 7.07. So we get x minus 5 equals plus or minus 7.07. I just took the square root of 50. Now, 2 answers. So let's see if we can get 2 answers. So we get an x minus 5 equals, well, it equals a 7.07, right? And I get an x minus 5 equals a negative 7.07. And let's just solve. Plus 5 plus 5. 12.07 is one answer, approximately. Plus 7 plus 5 plus 5. The other answer, what is that? Is it going to be a negative 2.07? Hold on real quickly. and it is a negative 2.07, approximately. Okay, so homework. And I want everybody to do it, because if we don't practice, we're in the same boat. We have to practice. We need to do our homework, you guys. You need to do your homework, please. Okay, so our homework today is going to be found on page 110. And most of it is just transforming these. So page 110 and 111. I want you to do 1 through 20 all. Okay. On example 1, I'll show you real quickly. They want the nth root, so they want the cube root of a negative 125. Okay. Get the answer either with a calculator with your superior brain. Number 4, that's like a square root of 64. Okay, again, use your brain. These, we're just going to go ahead and redo it, okay? There you go.